Hi everyone, it's Alyssa and welcome to Tricky Math Tuesdays. So today's tricky math problem is based on this shape right here. I tried drawing this freehand a couple of times for this video and it was disastrous, which it probably would have provided you guys with some amusement, but here we are. It was so bad. So what do we have here? We have a square that has had 4 half circles inscribed in it. So we got our half circle there, our half circle here, half circle here, half circle there. And where it overlaps, those overlapping areas, they've shaded. So the problem is they're going to say, okay, if the side of this circle is 8, what is the area of the shaded part? What is the area of that? Okay, now some people when they look at this are going to say, oh, is there a formula? Is there a way I can figure out what these shapes are? I'm going to turn off the ink to shape feature because I figure that's going to cause problems. Okay, there we go. Get rid of that. I don't know what it was doing there. What on earth is it doing? It's having a spaz fit. I'm not writing on that. That's not me. Wow. Okay. Well then, that was interesting. So my whiteboard has apparently become sentient and it's about to take over the world. All right, so we have this square. And as I was saying, some people are going to look and try to figure out if there's a way, like a formula for these pieces. The better way, and to my mind, my way of thinking, you're free to disagree with me, that's your right, is to find out the area of these white pieces and subtract them from the area of the square. Well, how do you find the area of those pieces? Well, first let's start by looking at these. Can we all agree that these 4 pieces are identical, right? So we have 4 identical pieces. So let's say if I was to cut them in half like this, that's not great, but it's not, the worst line ever. There we go. Okay, that one's better. Okay, so if I cut them in half, then I would have 8 identical pieces, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8 identical pieces. There's our baseline. Next step, I'm going to imagine that I take this, I cut it in half, and I take this half over here on the left, and I move it, and I put it right next to this one. What would I get if I did that? Well, here's what I would get. I would get, let's scoot it over a little bit, so I would get this. Let's enlarge this a little bit. There we go. I would get this, right? All I've done is I've moved that left side and I moved it over to the right side. All right? And so now I still have these 8 identical pieces. So I cut these in half right here. I have 8 identical pieces. So inside I have 4 pieces, and then outside I have 4 pieces. So these 4 added together equal the white space in the middle. Everyone with me? All right, so how could I find what the white space out here would be? Because if I found that, then this is the same area as those 4 small pieces put together. So if I were able to find, the area of these white spaces out here and then multiply by 2, it would be all the white space in this figure. Well, if we pretended that this was filled in as well, what would we have? We would just have a solid circle inside I'm going to erase those 4s because that's not the radius. That was me saying there's 4 pieces. That's not the side of the square. That's just me saying there's 4 pieces. I don't want to cause confusion. The side of the square is 8. Okay, so back to this. I would just have a circle inside a square. Well, what is the area of the square? The area of the square, and I'm going to write this up here, the square, we know one side is 8, so 8 times 8 is 64. The area, and I don't know the units, it's 64 something squared. Okay, and then I have my circle. What's the area of a circle? It's pi r squared. Well, what's the radius? From here to here is half the side of the circle, so the radius there is 4. So the radius of the circle is pi times 4 squared, or 16 pi. That's the area of the circle. So if I take the area of the square and I subtract the area of the circle, I'm going to get the area of those 4 external white pieces, the little pieces that go like this. Okay, so 64 minus 16 pi equals those 4, the area of the 4 little pieces, 4 pieces. Well, I have 8 pieces, 8 white pieces total. So what's the area of the 8 white pieces? Well, I would multiply this 4 pieces by 2 to get 8 pieces, this area by 2. So the area of the 8 pieces, I know this isn't a standard equation, but I'm just trying to make it very visual here, would be 128 minus 32 pi. That's the area of the 8 white pieces. Now, we're in a position that we can say to find the area of the red pieces. The red pieces would be, I'm going to write this in, let's say in, purple. I haven't done that in a while. I'm easily amused. I would take the area of the square minus the 8 pieces, and that would get me the red shaded area. So what is the area of the square? We've already established it up here. The area of the square is 64. And I'm going to subtract the area of the 8 pieces, 128 minus 32 pi. And that is going to equal my red shaded area. Now, since I am, there it goes again. What is with it? That just drew that and erased it on its own. That's so weird. I'm not touching the touchpad. I'm not doing anything. Ooh. Okay. So, man, that's weird. I have just to reboot this computer after this. So, to subtract this, I'm going to change this to plus, a minus, and a positive. I'm going to distribute that negative. So 64 plus a negative 128 is negative 64 plus a positive, now 32 pi is the red shaded area. And I can reverse that just to make it a little more easy to read. 32 pi minus 64 is the red shaded area. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.